Hokie dokie. So in this problem, I'll go through, I don't know, I think 5-ish problems or versions of this problem in Excel, and I'll try to explain it kind of using the empirical rule visual of this normal curve along the way. So they say, according to the empirical rule, what is the probability, what is P, for which the z-score is greater than or equal to -2. So let's define a couple things. Z-score represents the number of standard deviations away from the mean. So to put that into perspective here, to kind of define what's going on with this empirical rule, we have this curve, this bell-shaped, what is known as a normal curve, with basically it's defining the area under this curve as percentages. So from start to finish, from tail end to tail end, is 100%. And if we split this right down the middle, each side has 50%, right? And in the middle is the location of the mean. Every time, all the time, using the empirical rule, the mean starts right in the middle where this, main top of the bell is, whatever. And each time you go 1 and 1 over, you are going 1 standard deviation over. So if you go 1 standard deviation to the left and 1 to the right, you've filled out this 68% of the total 100%. If you go 2 standard deviations, 1 and then 2 to the left and then 1 and then 2 to the right, you've filled out, I guess, the area of 95%. My mouse is covering it every time, or that pop-up thing. But 95% of the whole thing if you go plus and minus negative, or so plus and minus 2 standard deviations from the mean, from the center. And now it only kind of goes out to 3 standard deviations both ways. So if you go 1, 2, and 3, minus 3 standard deviations, or 1, 2, 3 plus 3 standard deviations, you have almost the total 100%, 99.7%, and there's just like little tidbits of area missing, little percentages here on the tail ends. But that's sort of the idea. So to kind of relate it to this problem, what they're asking is, what is the probability? In other words, what is the percentage of the area under this curve? What's the percentage of this curve that is greater than -2? Again, z represents the number of standard deviations. So when we see -2 here, it's talking about going 1, 2 standard deviations away from the mean. So you're going in the negative direction, 2 standard deviations. So from right here, they're saying, what is the percentage of z's that is greater than -2? So to be greater than this line here, what they're asking for is, what is the percentage of this, this, and this all added up? Okay, so that's what we're looking for. So we could definitely just like add that up, but I'm going to show you how to use Excel to just calculate it real quick. So there's a function that is norm distribution, but what we'll do is type norm, and there's a specific one that I recommend using that is NORM.S.DIST. When you click on this, it tells you to type in a z-score, right, a z value, and then it says cumulative. Cumulative just means what does the total area under the curve add up to? And we've been saying it's 100%, which in terms of values, that's just 1, basically. So 100% is 1. So what we'll do is type in the z-score, -2, comma 1. And now let's talk about what this is giving us. Every time we do this, we calculate this, you will always be naturally getting the percentage that is to the left, right? So 2.35 from here onward, they're saying it's 2.275, which maybe I don't agree with. Maybe this is a rough empirical rule, but regardless, this approximately 2 point something percent is this small sliver, right? And this would be the answer if this question had said z is less than -2. But we don't want z is less than -2. We want z is greater than or equal to -2. So rather than have this value here, we're going to do 100% minus that value there. And so let me enter it as a function. 1 minus a1 gives us this 97%, 97.7%, which is, 97.5, I suppose. And so that's pretty much the idea here. So I feel like percentages are off. I don't know. Let's keep it going. Let's see how the others work out. So basically what I'm recommending is let's just use Excel for all these. So we're going to do NORM.S.DIST, and we're putting the z-score, so 3, 1. And in this case, again, they want the probability or the percentage that's greater than z is 3. And so this is giving us the less than. So when we go 3 standard deviations, again, z equals 3 means we go 1, 2, 3. And this 99.9% is giving us all this area to the left of 3 standard deviations. So we want to do 1 minus this and get this basically 1%, like 0.0, or no, I think it's just 0.1%. Yeah, it's 0.15%. And that's the percentage that is to the right. Okay? So that is the percentage where z is greater than 3. So we're just getting this little sliver that is 0.15% or so. All right, let's keep it going with these. Let's see what else we have. So z greater than -2. I think we've done that one already. Same deal. So let's do this one. Probability of z being between 0 and 3. Okay, let's clarify what they're looking for here. They're saying when the data point is 0 standard deviations away from the mean. They're basically saying from z equals 0, which is right in the middle, all the way to z equals 3. What is the percentage here? And we already know that half of this curve should be about 50%. So really we could use that logic and say it should be 50%, or we can type it in here, and let's talk about how to do that in here. If we do the same thing, we can just change, actually we already have the value for 3. So we're going to keep this value here. So 3 and 1, again, this is giving us that whole, pretty much the entire percentage of the curve that is 100%. But then if we do this, we do a separate one where we do NORM.S.DIST with 0. So we'll do 0 as the z-score, 1, and we get 0.5, which makes sense because at 0, it's giving us the percentage to the left of 0, so 50%. So really, if we just take this minus this, we will get the difference between here and the middle, between z equals 3 and z equals 0. And so if we do just equals this minus this, we get this 0.498, something stupid close to 50%. All right, let's keep it going. What else do we have? We have finally some less than. So these are very direct. They're much more direct than what we've been doing. So again, we can just change the z-score to -2 and keep the 1, hit enter. And again, this is giving us the percentage that is less than or to the left of -2, and that's about 2 point something. So our best answer is 2.5 based on this, right? I think I might have one more. Nope, actually that's it. Okay, so I hope this sheds some light on this. The biggest thing I'll say, hopefully everything's stuck with the greater than or less than. If it asks for greater than, like these two, you'll calculate it using the NORM.S.DIST, and then you'll do 1 minus that value. And if it's less than, you'll just be able to type it in like we did here and get the answer. If instead they give you an interval of values, then you will find the NORM.S.DIST for the first one and then subtract the NORM.S.DIST for the second one. And so to do it all in one fell swoop here, we're going to do 3, 1, and then we'll do it in the same cell, NORM.S.DIST 0, 1. So this might be a good setup to reference for this one. You hit enter and you get the 49.8 right away. So I hope this helped. I felt like I was stumbling over my words a little bit, but I hope this is enough to get you through this problem. And hopefully the visual makes sense. Maybe not the best visual in the world, but feel free to Google empirical rule and find whichever visual you prefer regarding this material here. All right, I'm done now. Hope this helps. Let me know if you have any questions. All right.